Welcome to a GCBASIC video for microchip. This is I'm reaching out for help in the ticket, and this is to set the scene with the issue. So this all relates to I2C. Okay, so I'm trying to develop the GCBASIC compiler, and I validate every chip. So Q24 validation is stopped at the I2C challenge. That's my challenge, not your challenge. I've gone through a whole series of tests already, and those have all been published. That's fine. And now what I was trying to do was just use I2C to discover the device and put it on the screen. And I'll show you what that should look like. We do this. I do this for every single chip that you release. Okay, so that we know that it works. For those coming to this from support, we're a compiler, open source, PIC AVRs and LGTs. As I said, Q24 is the next one, and we generate common code across these chips. Doesn't really matter. So for this particular one, this core compiler diagram doesn't really work because I have hacked this about. Not hacked it about. I'm not using any of the libraries because clearly I don't want to muddy the water. I'm using PKS over here as the linker and assembler. Okay, so that goes into here. So I'm generating a hex file that is based upon a .s source. Now I will walk you through that in a minute. What was that? Okay, what have I got? I've got a prototype board, and the only thing that's of interest here is I've got a I2C device attached correctly, and I can prove that because I can bit bang it. I could use I2C to bit bang this out, but I need to get the hardware verified, otherwise we have a problem. I've got many things connected to this chip. I draw your attention to port C. Port C here has got attached to it a clock on 4, a SDA on 5, a terminal attached to a TTL here, and the VDIO has the correct voltage applied to it. So what we've got is, VDIO 2 is set up correctly. I've got transmit for USART here, and I'm using these two here for I2C. Okay, and I've done this hundreds of times across hundreds of chips. So I sort of know, but not this particular chip because Q20 worked fine, but this one is not working. How have I got it set up? I've got a GLCD device connected with a SDA and a clock line, and it's pulled up high. And again, this is a standard bed I've got here. I'm not even going to bother to show it to you. Standard device on a standard test bed that I have run thousands of times over the last 15 years. Okay. And this is what I expected. I expected an acknowledgement back from the chip using the hardware I2C registers. I'd check a bit, and if it responded, I would know it was there. But that is not working at all. It's just gibberish. Okay, all right. Now I'm just going to show you some oscilloscope stuff, which will be impressive, hopefully. Do that. Good. Okay, so here we go. I've got an oscilloscope hooked up to here somewhere. Where is it? It's here. Why it's not very good. Oh, there you go. There's the clock signal. I'm sending out nothing, by the way. The chip should be sending out nothing. But if I'll go into let me show you a protocol analyzer. Protocol analyzer, I'll do a start on that. And that is also clocking out zeros and thousands of them. It's just, the bus is flooded, okay? You might go, yeah, so what? Well, all I'm trying to do is, all I'm trying to send out is, all I'm trying to send out is 78 hex and a 0, and then we're monitoring what's happening. That's all we're doing. And now what if I can't get that to work? So what I'm doing here, I've got a protocol analyzer working, and I will leave that running. I've got an oscilloscope running here, and I'm going to show you what happens on the scopes to start with, then we'll look at the source code, the .s source file. I am waiting for the clock signal to drop. It is currently passing the compilation to PIC-AS. It is currently programming it with a PIC-Kit 4. Doesn't matter what the programmer is. I've tried other programmers and they don't work either. Okay. So that's just doing its programming cycle. It's quite slow. Let me just check that yeah, it's still downloading it. Okay. Don't you tell me that. Oh, there you go. That's the PIC-Kit 4 doing its funky stuff. Okay. Well, this is using the command line utility. As you can see, if the internet's slow, it is slow. I'm only using a PIC-Kit 4 so that you guys feel completely. Oh, you go, yeah, okay. You can see it. It's now waiting for the signal to come back, and there it is. It has just sent out the registers have been set up. It sent out a signal. What signal did it send out? Well, we can look in here. If I stop that and I zoom out in here in this protocol analyzer, I can see there was a high event there on the data line. And if I zoom in on that event there, look, we will see exactly what we see in the oscilloscope. It sent out, for those who haven't got magnifying glasses, it says 78 ACK. And then it starts streaming zeros. Look at the shape of this. It's got 8 clocks. There's a stop at the end, a start and a stop at both ends. And it sort of, if you look at it, that's 78 because it's got the right number of bits set. Look, it's got 7 set in the high nibble, and the top bit of the lower nibble is set, so therefore that's 7/8. We know that. We can see that because we're all geniuses, right? And that's what we saw in here. Inside of the oscilloscope, let's just move that along a bit. That's the stop. Let's look at the actual. Oh, I didn't. For some reason, we're going to have to live through the pain of data capture again. Okay, I was not zoomed in sufficiently. We're going to have to program it again. I am so sorry. Oh, what a pain. Run. That's the oscilloscope capturing all the zeros that are just happening afterwards. It's just spewing out these zeros. And I'll show you the source code eventually once I show you what's happening. Rather than show you the source and wait for the end, I'm showing you the end state. Now, I'm tempted to move to a PIC-Kit, another alternative programming method, a PIC-Kit 2, because it's just faster, okay? It just takes a few seconds. I cannot explain to you why it's taking so long. I'm sorry. We're waiting here for it to complete the programming cycle. And it should have done it now. Single. Oh, sorry, I'm going to change over to PIC-Kit 2. I just can't be bothered. I'm sorry. It's the same result. I went to a PIC-Kit 4 just to convince you, but I just need to change the setup. One moment. All right, I'm doing the same thing. So it's using PIC-AS to compile the source on a .s source. And then what I need to do on the oscilloscope is when it goes through the programming cycle, is just capture the first event to show you that 7/8 that is going out. But then the other byte I'm trying to send, which is 0x hexadecimal 55, is not going out. I have no idea why PKS is taking this long. Normally that's lightningly fast. Okay, downloading. What have I done? Oh, oh, got it. I got it. I got it. Let's zoom across there. Let's zoom in. Remember what we're looking at is for the shape of the 7/8, and you can see from high nibble, low nibble, that is definitely 7/8. But then if I move across, the stop signal comes in, and then I get all I'm getting clocked out is zeros. Exactly the same as the protocol analyzer. They are the same thing. What's happening? I have no idea. So let's look at some source code. I'll open up I'm going to show you a couple of things, but I'll just send you the .s, okay? There is no way you can write .s like we can write .s. Anyway, look, initially, this is what's in the .s source, okay? I guarantee it. I'm initializing the PPS with the configuration directly from MPLAB code configurator. It's just pasted in. I have the data ports are set to outputs just because that's how you like them, okay? And I'm being very clear about the code. I've then taken the initialization from I2C initialization in MPLAB X6.20 because and the only thing that's not in here is any reference to bits because bits don't exist in our world, okay? All right, it's the same register, the bits just don't mean anything. And it's the same code. The only change I made in here is that I just had to make sure that the register bit was spelt correctly. It wasn't spelt correctly over in MPLAB because you use different setup files. But I pass all this over to .s file, so it doesn't matter what I type in here. It's the .s that's going to be perfect. I set the address in the ADB1. I clear out ADB0 just to make sure that's correct. I then load up my data into the TXB. I then set my counter after I have validated that the NDR or the BFRE are high. And that's what it says. It says you can only update the counter when these bits are set. It's OR, okay? And I've done a sort of an OR thing in there to get it done very quickly. The rest of this is all just debug. I then set the start. That is the end of the program because this is waiting for a switch input to do it all again. It's not looping around because I have a serial terminal connected up and it says here the word ended, okay? And that ended comes from here. And if it was looping around, it'd be looping around forever, okay? And these are all the registers. They all look correct. They all look absolutely spot on. I cannot distinguish what is happening here. So I'm getting events happening. It thinks it sent out the data as per the program. In the .s source, here is the source, and this all gets sent into PKS. So PKS is validating this source. It's compiling it. And then I was using PickKit4, but it was just too slow. And you might go, no, there were lots of errors for PKS. No, there's not, because I'll show you the, oh, I'm so sorry. Reveal that, Control B. I just opened the hex file by mistake. Here's the error file that's been issued. I'll shut that hex file. There's no errors in here. This is just been compiled, and it's got 3 missing configs in my .s source. These all refer to SAF, and because we top load the code, so we bottom load the code, we're not overwriting SAF. SAF is not going wrong. What do I mean by top loading the code? I'll show you it in a programmer. Here we load the code from 00 and it terminates out at, I guess, not very big program in reality, because it terminates out at 80 something. There you go. Look. Terminates out at 8C2. And you can go, no, it doesn't. Well, I tell you it does, because here's the list file. It's just compiled. And in here, if I look in the list file, I'll see the compilation. And the compilation for that, where were we? 80. Here we go. We got some stuff out the back end of here. Oh, 804. It's an align statement. There's the last byte going in there. Okay. All right. So what's going on? I have no idea, because if I look at my source program, I have recap. I have used the registered but I lifted these direct from MPLABX, including the little hacks for the errata. I don't know why this is in here, because there is nothing in that data sheet errata that's around this particular chip. I'm totally baffled why that's there, to be quite frank. If we look in that data sheet, I've just opened it. It refers to Q43s, not 24s. It's a completely different chip. Or unless you're telling me that these are wrong, okay? Unless you're telling me these are wrong. That's actually quite an interesting point. I'm using A001 chips, A001 chips. But as they're not referred to as here, what did it think in? I'm just starting up MPLAB IPE. I should give you that piece of information, which is the chip I'm actually using. I think I've got the errata open for that chip, but I won't. I'll try and find it a different way. I'm just opening up the errata. So valid chips in here are A001. I got an A001. I can see none of what I'm seeing here in terms of the error I'm getting is in here. I don't understand what's going on, because I don't see this error. Remember, this is just streaming out data, and it's not sending out what it should be sending out. It should be sending out, per the source code, it should be sending out 78, which is the address, which it is, and it should be sending out 1 byte 0x55, because it's sending 1 byte because I have set the counter to 1. It doesn't actually matter. I've tried thousands of different parameters in here to try and get this to work. Do not get hung up about this language here. Get hung up about the .s source. If that's wrong, yeah, and it's obviously got lots of other stuff in there, but I'll work with you to do whatever you want. I have to resolve this. Okay. I was looking in the I powered up IPE. I powered up IPE to connect to the chip to show you that PitKit was the other PitKit software that we maintain. Okay, I actually maintain and sell. If you're porting back the correct chip. Okay. Gosh, this is really slow today. Okay, so it's found an A001 chip. That's fine. Device revision is exactly the same. We're looking at the right thing. Oh, you can't see it. That's because slight scaling problem. If I put it to full, I don't know. Let me just figure a way of doing this for you. View, read device ID. if I clear this, and there you go, there's the revision number there, look, A001. It could be this chip, could have a new bug in it. If it has, send me one, I shall test it, yeah, and I shall put the A001s in the bin, yes. But a huge video. I am so sorry it's taken 20 minutes, but I need it working. This works fine when I bang it out, okay? So that's what I wanted to show you. So new chip family, Q24, want to get it working. I have never seen this problem before, and I've been through the old chips, that's what I call the legacy chips, the change at the PIC 18, at the 16F 18855 types chips, then the K42s, they needed changing. I needed to put changes in for other Q43s needed the tweak, absolutely, but this is not working. I mean, the others just needed tweaking. I did not have to go through this. I just used our standard library, made a small tweak to it, and voila, it burst into life. But I am not using any of my libraries. Let me show you to reconfirm that. Look at the .s source. If we come to the top, there's no I2C setup apart from the registers that were lifted directly from MPLABX. It initializes the chip with a clock, it initializes the PPS, which we saw, and it initializes the USR. It then essentially walks through all the setting up all of the registers as per the source program. And they are documented, fully documented, so that you can understand them. Help.